Now in class 4 we discussed about alpha, beta and gamma decay in detail. Now let us see what is radioactive law. Very important one. Radioactive law. Radioactive law or decay law or exponential law. All these are nothing but radioactive law, decay law, or exponential law. All this. Now what it says is the rate of decay of radioactive element, the rate of decay of radioactive element or radioactive nucleus or number of nuclei disintegrating per second, that is dN by dt is directly proportional to number of nuclei present at that time. The rate of decay of radioactive nucleus or rate of radioactive decay or number of radioactive nuclei decaying per second is directly proportional to number of nuclei present at that time and is independent of pressure, temperature and chemical composition. It is the rate of decay is independent of temperature, pressure and chemical composition. What is called as radioactive law definition. Now what we have, dN by dt, let us say n be the number of radioactive nuclei present at a time t. So n is present at a time t. Initially at t naught number of nuclei are n naught. As time increases, what happens? This n going to be decreases. Initially at time t is t naught means at t is equal to 0. Let us say at t is equal to 0. Initial time at t is equal to 0. The number of nuclei are n naught. This is maximum number of nuclei. As time t increases, what happens? Number of nuclei n naught is going to be decreases. N naught is going to be decreasing. Now, therefore, according to this one, dN by dt is proportional to n. The rate of decay or rate of disintegration is directly proportional to number of nuclei present at a time t. dN by dt proportional to n. dN by dt is proportional to n. This implies dN by dt is equals to some constant minus lambda into n. What is lambda there? Lambda is disintegration constant. Or decay constant. Disintegration constant or decay constant. Negative sign significance. Negative sign indicates that as time increases, number of nuclei decreases. Number of nuclei decreases. So n is the number of nuclei present at a time t. At a time t is equals to 0. N is equals to n naught. Isn't it not? At time t is equal to 0, n is equals to n naught. N naught is the maximum number of nuclei. Initially it is 100. As time t increases, 100 becomes whatever. 100 becomes some 90, 70, 60, 50 like that. They are going to be decreases. Therefore, here dN by dt is equals to minus of lambda n. This from this equation, dN by n is equals to minus of lambda dt. dN by n is equals to minus of lambda dt. This implies integrating on both sides, integral of dN by n is equals to minus of lambda integral of dt. This implies log n to the base e is equals to minus of lambda t plus k. What is k there? K is integration constant. How can we get the integration constant? Using the boundary conditions or given initial conditions. What are conditions? At t is equal to 0, n is equals to n naught. At t is equal to 0, n is equals to n naught. This implies dn by n naught is equals to dn by n naught. Sorry. This we have to put this in this equation. Log n naught to the base e is equals to minus of lambda into 0 plus k. This implies k is equals to, this is 0, no? T is 0, t is 0, n is equals to n naught. This implies k is equals to log n naught to the base e. So the value of k is log n naught to the base e. This implies, now what this equation becomes? Now this equation becomes log n to the base e is equals to minus of lambda t plus log n naught to the base e plus minus lambda t log n naught to the base e. So keep it aside this equation. Let us say take it as a. Take it as a. Now from this equation, this implies log n to the base e minus of log n naught to the base e is equals to minus of lambda t. This implies log a minus log b, log a by b, log n by n naught to the base e is equals to minus of lambda t. This implies n by n naught is equals to n by n naught is equals to. So let us say, take it as equation 1. Let us take it as equation 1 also here. Therefore, n by n naught is equals to e power minus of lambda t. This implies n is equals to n naught into e power minus of lambda t. N is equals to n naught into e power minus of lambda t. This is very important equation. N is equals to n naught into e power minus of lambda t. Now you put t is equal to 0 here. Anything power 0 is 1. Then what happens? N is equal to n naught. We have taken t is equal to 0, n is equals to n naught. Same thing we got n is equals to n naught into e power minus of lambda t. Now as t increases, what happens? As time t increases, e power minus exponential decreasing function n is going to be decreasing. As t increases, n is decreasing. Therefore, number of nuclei left or decreasing. Number of nuclei left or decreasing. Number of nuclei left or decreasing here. Therefore, if you take a plot, of so here this is t, this is let us say nx, this is let us say n naught. T is equal to 0. At t is equal to 0, n is equals to n naught. As time t increases, the number of nuclei decreases exponentially. As time t increases, what happens? Number of nuclei decreases exponentially. You can see here n is nothing but n, that nx is nothing but number of nuclei left. Number of nuclei left is decreasing. 100 nuclei are there, they becomes 90, 70, 60 like that. The number of nuclei are decreasing. Now also you can another one also you can take. So number of, this is t, this is ny. So what is ny? Number of nuclei decayed nuclei. Decayed nuclei. If you take decayed nuclei, then what happens? Number of nuclei left increasing means number of decayed or increasing. Number of decayed or increasing. Isn't it? Number of decayed or increasing. Therefore, if you take number of decayed, this will be something like this. Number of nuclei decayed increases. Number of nuclei left or decreasing. Now, anyhow, from this equation, at t is equal to, in this equation, if you take t is equals to 1 by lambda, if t is equals to 1 by lambda, then what happens to n? Then n is equals to n naught into e power minus of lambda into 1 by lambda. This two gets, put t is equal to 1 by lambda here. Put t is equal to 1 by lambda here. Then what happens? If t is equal to 1 by lambda, this becomes n is n naught into e power minus of lambda into 1 by lambda. Therefore, this becomes n is equals to n naught into e power minus 1. This implies n is equals to n naught by e. That is equals to n naught by 2.718. 2.718. N naught by 2.718. Then what happens? 1 by almost 1 by 3 means 0.368. 0.368 n naught. That is equal to 6.8% of n naught, or simply 1 by e times of n naught. Now, how can we define decay constant? Decay constant is defined as, this implies lambda is equals to 1 by t, reciprocal of the time. From this equation, decay constant is reciprocal of the time during which the number of nuclei decays to 1 by e times of their maximum value. From this equation, here let us take this. At t is equals to 1 by lambda, n is equals to n naught by e, nx is equals to n naught by e. At t is equals to 1 by lambda, if t is equals to 1 by lambda, n is equals to n naught by e. Therefore, we define the decay constant as reciprocal of the time during which the number of nuclei decreases to 1 by n naught by e time, 1 by e times of their initial value. This is a decay constant. What is the unit of decay constant? Unit of decay constant is unit of lambda. Unit of lambda is equals to, what is unit of lambda? 1 by t, second inverse. Unit of lambda is second inverse. Another thing is, from this you have taken equation. We have taken equation like this. Log n to the base is equal to minus lambda t plus log n. This is something like y is equals to minus mx plus c format. This is y is equals to minus mx plus c format. So this is x is t and y is log n to the base e. Y is equal to minus mx plus c means the graph is something like this one. The graph is something like, so this is the decay constant on all that one. Now again we have derived another expression for t also here, another expression for t. So n is equals to n naught e power minus lambda t log n to the base e is equals to log n naught minus lambda t. This implies log n by n naught to the base e is equals to minus of lambda t, implies log n naught by n to the base e is equals to lambda t, implies t is equals to 1 by lambda log n naught by n to the base e. This is another expression for the time. Therefore, t is equal to 1 by lambda log n naught by n to the base e. This implies that t is equals to 1 by lambda into 2.3026 into log n naught by n to the base 10. So this is another expression for time period t. Okay.